Hi everybody, today we're going to break down a tutorial that I wrote a couple months ago about React 3 Fiber. And this is an intro tutorial. It's really simple. It's basically just adding a sphere and a couple lights to a scene to build kind of a basic 3-point lighting rig. So I think this is a good intro tutorial just because it gets you used to using Three.JS objects as components, which is basically what React 3 Fiber does. It kind of maps the Three.JS API onto a declarative React API. And what I mean by that is basically that all of these components that you see in this project, like the plane buffer geometry, a mesh standard material, uh, sphere geometry, for example, all of this stuff is like an exact equivalent in the Three.JS docs. So like whenever you see in a React 3 Fiber project a lowercase component like this, the first thing you should be thinking is, well, let's look at that in the Three.js docs, because that's going to tell you everything you need to know to use the component inside of React 3 Fiber. So let's kind of break down this project a little bit, and then we'll get back into that point. So this is a one-page or a one-file project, right? So I wanted to make it as simple as possible. We have a canvas component at the top, and then we have a ground plane, a backdrop, and these are just plane geometry to kind of wrap our project up here. Like this is the ground plane and this is the backdrop. I can show you what happens if we take that out. There, we're just left with our sphere. So kind of see what the point of those are, just to give our scene more of a 3D feel and show a little bit better the position of all the lights. So we have those, and then we have our three lights, a key light, a fill light, and a rim light. And if you're not familiar with what a 3-point lighting setup is, this is a 3-point lighting setup. And basically a key light is going to generally come from one side on the front. And in this case, it has a warmer tone here. So this pinkish light is the key light, and it's also the brightest light. It is kind of your main light. And then the fill light comes from the front also, but on the other side. And the point of that is to sort of fill in some of the shadows that would be cast by the key light. And that gives you a nicer gradient across the sphere. So if I were to comment that out, I'll show you what I mean. So like, look how this whole area is just black now. It's kind of completely washed out. I mean, this still looks okay, but having all three of those lights gives you a really nice feeling of depth and a really kind of clean lighting. And then the rim light has a different purpose. So the rim light is actually just to give you a little bit of nice highlight for contrast. And in our case, our rim light is basically just providing this little area of bright white here on the top. And that helps separate the object out from the background. It is kind of the main point of that. And see, if I comment it out, it goes away. And it looks fine with that, but this is what a 3-point lighting setup is. These three lights to give you a nice shading. Okay, cool. And then finally, we have our sphere component inside the canvas. And that is obviously just providing this geometry that we're lighting here. Okay, so I mentioned earlier that the way that React 3 Fiber works is basically mapping Three.js classes to components that we can use. So what does that mean exactly? Well, what it means is that if I were to look at my sphere here that I am rendering into the app and into the canvas, what is it that I'm actually rendering? I'm rendering a mesh, and the mesh has some props here, and we'll get into what those are later. But then the children of the mesh are two more components called sphere geometry and mesh standard material. So why does it work like this? Well, the reason is that, like I mentioned earlier, basically every single component that we use from React 3 Fiber has an analog in Three.JS. So a mesh is a class. And if I go look at the documentation for a mesh in React 3 Fiber, notice here where we're creating the mesh, the instantiation of the mesh, the constructor, takes in geometry and takes in a material. So like in this example, they're going to create some new geometry and a new material, and then they're going to create a new mesh by calling new 3 mesh and then passing in the geometry and material. And then the last step that they do is just add the mesh to the scene. Now going back to our example, we don't have to worry about adding the mesh to the scene. That is happening automatically because of React 3 Fiber. That's kind of the power of React 3 Fiber, is that we just say we want a sphere. We don't have to worry about some of this detail where we're like adding meshes to the scene or removing them when we don't want them. We just work like a normal React app. But what we do need to worry about is kind of constructing our sphere here. And so we have a mesh, and then what are the children? Sphere geometry and a mesh standard material. And so that is like literally exactly what you would pass into a mesh when you're building one in Three.js. So that's kind of the pattern. If you want like some class from Three.js in React 3 Fiber, it's usually going to follow this pattern. So this is a box buffer geometry and a basic material, but we're actually passing sphere geometry and a mesh standard material in to create this mesh. And that's cool. I mean, that is just kind of a different option, but we could have easily done this. We could have said box buffer geometry. And okay, so that's not doing anything. Why is that? Well, it's because the arguments for box buffer geometry are different than those for a sphere. So these parameters are getting passed in as an args prop on the box buffer geometry component. That's the other common pattern in React 3 Fiber, is having the parameters for a constructor being passed in as a prop. So you might be asking yourself, like, why does the mesh take its parameters in as children, but these children components, you actually have to use props? Well, I mean, it's basically just because you're using meshes all the time, and also that these are classes that are going to be passed in. It's kind of just a decision that React 3 Fiber made for nice usability. But at the end of the day, just think of it like this. Like, you're creating some geometry, creating some material, and then creating a mesh using those two things as children. And you'll see that same pattern here repeated for the backdrop and the ground plane, right? So these are all of our 3 geometry objects. Well, it's a cube, but it used to be a sphere, so let's go back to that. The sphere, backdrop, and this ground plane. And yeah, the ground plane and the backdrop work the same way as the sphere. So yeah, we got a mesh again, this time using plane buffer geometry. Every single one of these things you're going to find in the Three.JS docs. And the plane buffer geometry takes 3 parameters, although the last one is actually optional. And those 3 parameters are the width of the plane, the height, and the number of segments. And so what we're saying here is that our plane buffer geometry is 100 wide and has a height of 100. So what would happen if I change those to 2? Like now it's just this really small plane. So that kind of shows us. Same thing here, if I just change the height to 2, now it's still long, but only has width of 2. So hopefully you're kind of noticing the way that this is mapping here. So the arguments prop is how we're creating the plane buffer geometry. I could add in segments here. It probably won't be noticeable because we're not really doing anything with them. But we'll see an example in our sphere in a second of segments and how those work. And the same thing with the material. We haven't really talked about that yet, but the material also has props, different ones from a plane buffer geometry. But if I were to search for mesh standard material, here we go. So the mesh standard material has all kinds of different parameters that you can set, but the only one that is really kind of required is the color. I think it just defaults to black. Again, try that. Yeah, it still works the same, but we can change the color as a prop. So like I can make my sphere red or blue. This could be also I'll just reuse our light color. Should be like a pinkish color. Yeah. So this color will change the material. Now, any of this other stuff that you see in the Three.JS docs is also going to be a prop. So a lot of the time when you're working with React 3 Fiber, you're going to go into these docs and look for settings. So like let's see here, flat shading and wireframe are 2 options that you can set on the mesh standard material. So what if I set those as props on the mesh standard material? Let's start with the flat shading. And these are Booleans, so simply having this here will make this prop true. Okay, wow, so notice what happened. We got all these new lines here. And basically what we're seeing is each individual face that is making up the sphere. These faces were always here, but with flat shading turned off, it kind of blends the shading of each face together. And with it turned on now, we're kind of seeing the ugly truth of our sphere. Which brings up another point. I mentioned earlier with the planes that there was a kind of a geometry division argument. Well, for a sphere, that is also true. And so if we look at our sphere geometry that we're sending in as a child to our mesh, and then pull up the docs for that. Okay, wow, so this is a pretty ugly sphere. And the reason for that is this width segment and the height segment are very low in this demo. Down here, they're setting it to 32 and 32. Well, what does that look like? So if you up the width segments and the height segments, suddenly you have a much better looking sphere. Basically, this is just telling Three.JS how many planes to use to construct this sphere. And the more you have, the better it's going to look, but also it's going to, increase the performance cost a little bit. Although 32 is not a big deal at all. What happens if I just knock this all the way up, even with flat shading on? You kind of can't even notice it anymore. And then if I go way down low, it's going to start to look real funky. So this is a sphere that only has two height faces and two width faces. So like 1, 2, and go up to 3. You can't really see that, but if I add a third height face, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So you get the point. Basically, a sphere has a second and third parameter that decides how many width segments and height segments you're going to start with. You're pretty safe with 32 and start off flat shading and it'll look pretty good. If you ever did notice some faces that you could see here though, that's how you could fix it, is increase the number of args. All right, cool. So that is kind of the most important thing about React 3 Fiber, is just to start to get a feel for how these components match up to classes in Three.js. Every single one of these is going to be in here. So even our lights, like rect area light, that's going to have an equivalent class. And that's where you're going to find out all of the settings that are available to you. Yeah, so lights are a little more complicated, but not too much. And in this case, we're using rect area lights, which is basically just like a rectangular area light. And there's a lot of different lights, and the reason I use these for this demo is mostly just because they give a nice look to the shading. There are some downsides to them. For example, as far as I know, right now they don't cast shadows correctly. There are some workarounds that you can do, but that's kind of above and beyond the scope of this demo. Some of the things that you can do, obviously, though, is change the intensity of the light and the color of the light, also the position and rotation of the light. See how they're set as props here to make it a little easier to do. The key light gets passed in brightness and color, and then that's passed right along to the rect area light, which you'll notice are props of that class. Although it's actually, so the rect area light extends the light base class, and the light base class is what has a color and intensity property. You'll notice this sometimes also as you're working with React 3 Fiber, just situations where like you're using a subclass of something and it has all kinds of properties on it, but it's actually just extending those from the base class. So always check that when you're looking at Three.js docs. Go ahead and look to see what base class is being extended. Usually it'll tell you down here in the properties. So we got color and intensity. That's really the big ones. Just to show you what happens if I change some of that stuff around. I can change the brightness of the key light down to 1 and suddenly see how the pink coloring is much more subtle now. Or I could turn the fill light way up to 9 and now it's like totally washed out over here, super bright. And then obviously these colors work the same way. So I could turn that light totally red. And what's happening there is basically I'm just changing the property of the rect area light through a prop. Yeah, and I mean, that kind of is the basics of React through Fiber. Just being aware of how all of these components are being provided to you and how they match one-to-one with a Three.JS class. The only difference is that as a convention, the class names are lowercase, lower camel case in React through Fiber, and the class name is actually just the uppercase version of that. And as long as you know that and are able to kind of start messing around, eventually it'll become sort of second nature. And you'll just be able to go to the Three.JS docs and see, like, okay, well, I know I have some polyhedron geometry or ring geometry. What if I want to use one of those? Let's do ring geometry just because it's a little simpler. Well, I know that I can just go right back into my component and I should be able to type in ring geometry, except as lowercase. Sorry, I'm changing the wrong thing. I was changing my material, but for the geometry, we should be able to go ring geometry. And that looks super weird, but that's just because my settings are off here. So let's look at what the constructor is. So we have an inner radius, an outer radius, and then a couple of different segment options we can set. So let's try this. There we go. So now my inner radius is 1 here, and the outer radius is 2. Sweet. And that's basically the way you work. If you wanted a torus, you would just go through the docs and find the torus geometry, refer to that, and build it up here in your component using the props that are available to you. If you want to move things around, that's pretty much always the same. Yeah, so like the ring geometry and the sphere geometry all have their own special props to define the size and everything, but the transforms that are common to all geometry, that you can just do right in the mesh, right? So a mesh has all kinds of props as well, like that actually is defaulted to true. So I could set visible to false and hide it. I could also move it around using the position prop, which takes a vector array of x, y, and z coordinates. So z is kind of forward and backwards. So I can move it closer to the camera by increasing the z value, or move it farther away from the camera. And move it right and left with this first value, and then up or down with this second value. And then rotation is the same way. It's another XYZ vector here. So we can rotate it on different axes. Let's see if we can get a better rotation going. There we go. All right, so that's the basics of React 3 Fiber. I know this tutorial doesn't cover a lot of stuff that you might be interested in, like animation or like post-processing effects, and doesn't really get too detailed on materials. But hopefully it gives you some idea of how React 3 Fiber works, and just the way that it takes all of these classes that are provided by Three.JS and lets you use them inside your React components. That's really the power of React 3 Fiber. And I hope you are interested in it and go play around with it somewhere because it's a really cool project. Thanks for watching. Bye.